Welcome to the Joy of Coding!
Hello, and welcome to episode 210 of The Joy of Coding. Hi, how are you doing? My name is Mike Conley. It's so good to have you here. Going to be hacking on some Firefox stuff today, as per usual. Like last week and the week before, and maybe the week before that, I've started to lose track. I'm working from home, and so that, I'm streaming from my basement. Let's see. Let's hope that the Wi-Fi holds out. I hope things go okay. That's why the lighting might be a bit weird. But hey, we're just trying to do our best here. Just trying to make it happen. Crunch, crunch. Enter the captain. Let's see what's going on today. So first off, as a general reminder, I always say this at the start of every episode: no plan survives breakfast, because things like the Wi-Fi could just sort of like fall out for me. It might just like completely fail for me. That could happen. So none of this is pre-scripted really or pre-planned. I don't actually know what I'm going to be doing today, to be completely honest. I have the links wrong in the agenda for the music. Like all sorts of things are kind of like I'm throwing it together, but that's okay, because that's how a lot of these episodes go, and we're gonna do some interesting work, I think. But just so you know, I'm making it up as I go, so if it seems a little disorganized, it's because I'm making it up as I go along. I'm going to be actually capturing software development in the raw, so I'm not writing pre-written solutions in my JavaScript or C++. It's live hacking. I'm coming up with solutions as I go, and some of that might lead to real patches, and some of it might end up being thrown away, and that's how it works. So just so you know, that's what's going on. And the second thing is that the agenda that we're looking at is something that you have access to. If you're watching this on YouTube, check out the video description down below. If you're watching this on, I have to open up Twitch actually to send it to the people on Twitch. If you're watching this on Air Mozilla, check out the video, the handout section. There's a link there. And if you're watching this on Twitch, I'm about to drop it into the Twitch chat. One sec. One moment. The link to the agenda goes in the Twitch chat right now. There you go. So now you can start clicking on links. We also have an episode guide, a completely viewer-driven, viewer-powered episode guide, just for viewers like you to help expand upon the episodes. Maybe if you've got your own corrections, or maybe you've got notes, or maybe you want to talk a little bit, like add some additional bullets about things that went on during the episode that might be useful if people want to be able to find them, maybe with a search engine or something. And you can send me pull requests to that repository where the episode guide is. It's very straightforward to add episode guides. In fact, there are probably some pull requests in the repo right now. Let's take a look. And you know what else I'm going to do is I'm going to turn on some background music, because that's been quite popular. So this is another broke for free track or album. I'm gonna turn that down a little bit. If the volume is too loud or something, just let me know. Broke for free. This is from the Free Music Archive, so don't DMCA me, YouTube. All right, so I've got one pull request for the episode guide. Let's take a quick peek. That might still be too loud. Should probably just have like a known good volume level. If that again is too loud, let me know in either the Twitch chat, which I do kind of have open in the background, and I have the live hacking Matrix channel in the background. And if you're not sure what I mean by Matrix channel, there's a link in the agenda on how you can join the Matrix channel, which is where I'm spending most of my time observing chatter. All right, so SmurfD sent episode 209. He writes, let's see if this went well. I was not first able to see this pull request on my Conley Joy of Coding episode guys. I usually can, but had to go to such and such for some reason. Well, I see the pull request, so it worked out. Let's take a look at the change itself. So yeah, last week was March 25th, is episode 209. And let's make sure that the links are all correct here for the video. Yeah, March 25th, episode 209. Make sure that the correct link for the agenda. Yep, that looks right. And let's see what got covered here. Pandemic edition, the Wi-Fi did hold out. Yay! A link to the background music, and then the stuff that we worked on. Oh, we were working on the page thumb protocol last week. So, really interesting. I got it working. It turns out there was like one last little thing. After we did our rebase last week, I was able to get the page thumb protocol working. I can actually show you that in a second. Yeah, applying a 2-year-old patch was tricky. That's what I did last week for the Moz page thumb stuff. And then I went through what one needs to do in order to reproduce a performance issue and a memory issue, and how to make those into actionable bug reports. Good. This is a great bunch of notes from Smurf D. So as usual, thank you Smurf D for the excellent addition to the episode guide that is now merged. All right. So let's start by me showing you the page thumb thing. I think I can do that. Actually, maybe I'll try to figure out how I want to do this. All right, let's show you the page thumb thing. So I have to check out this revision, because there are 2 revisions with the bug. There's the part where I had the some people from the networking team and from the sandboxing team review the new Moz page thumb protocol handler, and that's just been accepted. And then there's another patch for reviewing the code that makes ActivityStream use the Moz page thumb protocol. So we have to check out the revision, the revision for the this one right here, actually using it in ActivityStream, so that both are applied. So I'm going to check that out. Hawker says, looks like today viewer count is back to normal. Yep. Last week was a very surprising amount of viewers. It was a little disconcerting, actually. I was worried about, you know, all of the traffic that I was seeing in the chat. I couldn't really keep up. Who knows what was going on in there, but you know, I'm glad it worked out. It seemed to work out at least. So yeah, invite your friends. Who knows? Maybe we can make the crowd even bigger. Maybe that's what we want. Maybe we want more of an audience. So while I build this, maybe I can talk a little bit more about how the patch works, what went on during the review cycle. Let's pump up the font. I can walk you through this. Yo. Moz page thumbs. You want to use the page thumb protocol, and it's got all of these lines of code inside it to make you get the thumbs for thumb's sake. It goes through IPC to make sure that you have permission so that you can see the thumbnails. Yo. That's how it works, yo. So what happens is, in the script security manager, we made it so that the Moz page thumb protocol can only be used in 2 cases. Either you're in the parent process, or you are running inside of the privileged about process. So the privileged about content process actually runs this. So that's like a first layer of security to prevent web pages from accessing this thing. But then we, excuse me, I just choked on some of my own saliva. Pardon. There's the other half of it where you want to make sure that the parent process can't get fooled into sending thumbnails to a compromised, like a completely compromised web process. And we do that later on in the Neko parent. This runs in the parent process. Here's where we receive the message. And like, if we realize that the process that we're receiving this from is not the privileged about remote type, then we just crash the content process. And that's generally what you do. If you're getting a weird message, if you're getting something that you don't expect from a content process, you should just crash it, because you know, it's probably not it's up to no good. And so, how do I want to walk through this while this is building? Well, while this is building, I'll walk you through, and we can see what this thing does. Oof, grammar. Okay, so the NSNet util business. This was the part that I needed to change, actually. So there was this handler for Moz page thumb in here that was confusing a bunch of our code. It was causing none of the Moz page thumb requests that I was testing with to go through the Moz page thumb handler. It was causing it to just like go through this code path, a simple URI mutator. And what I really needed to do was add an additional Moz page thumb like condition, I guess is what you, that's exactly what it is, condition to this list, just like Moz extension. And what happens here is we make sure that we're running on the main thread, because Moz page thumb, even though the URI stuff is technically thread safe, the Moz page thumb protocol handler calls into the Moz page thumb storage service, which is executed in JavaScript, and that it only should be running on the main thread. So this thing needs to run on the main thread too. So we fail if we're not on the main thread, then we get in the handler, and then we ask for the URI, or we tell it to handle this new URI. So that's the first thing. Second thing here, we register the Moz page thumb protocol handler through xpcon here, and then there's a bunch of header stuff. I already showed you this. This is what's doing the work in the parent process. Probably the neatest part about all this, actually, is that I was using, I adjusted the patch to use promises in C++. So in C, you might be familiar with promises from JavaScript. Promises are kind of a nice way of encapsulating asynchronous, I have a hair in my mouth, asynchronous activity, so that you can like chain tasks that occur asynchronously, and that you can use things like async and await functions in JavaScript to have a nice readable list of operations that periodically yield back the event loop. That's what a promise does. Whenever you're waiting for it to resolve, you yield back to the event loop so that like other stuff can occur. And we can do that in C++ too. I mean, promises ultimately in the lowest level are written in C++, at least in SpiderMonkey and in our DOM code. And so I was able to use something kind of like JS promises, but it's called Moz promise. It's a C++ promise-like thing. And so what happens is I created a function, or I modified the new stream function on the page thumb handler to return a promise, and then I can call then on it like I would any other promise in JavaScript. But then there's like a little more that you have to pass to it. Like you have to tell it which thread you actually want to run your functions on, your vendables, because you could actually have those functions run on any thread. In this case, I want to run on the main thread. And then what to do. This is like the resolve function, and this is the reject function. And in both cases, I actually want to call the resolver that was passed to this IPC message, because like the message handler, because no matter what, even if I reject, I need to be able to tell the content process what the result was. And in this case, like if a failure occurs, I log the failure, and then I just like resolve with null, and then the content process knows how to handle that. But in the success case, that we resolve with an input stream. And then over in the, this is just a bunch, we saw this is a bunch of like extension protocol code that was being reused. That's great. Probably the most interesting part of the page thumb protocol handler is how I made it use that promise thing. So here, instead of returning, before we were returning, where is the thing? New stream. Before we were returning an input stream synchronously, but we want to actually return that input stream asynchronously, because accessing it causes main thread IO. So one of my reviewers caught that, so thank you, Hike, for catching that. And so what we do instead now is I return a promise from this function, and like I will immediately reject in a bunch of like error cases. But in the event that things go well, if like I'm able to get everything that I want, a lot of discussion here, then what happens is I create in C++ you have to create a promise holder. That's what you can actually call like resolve or reject on. And then there's the promise itself, which is the thing that callers can call then on. And so then I dispatch a background task on a different thread that knows how to access that input stream, get access to that input stream off of the main thread, and then dispatch it back to the main thread. And so we resolve with that on the main thread here. We reject if things go wrong, or we resolve with the input stream, and we do that on this new background a runnable function that runs in a background task in a background thread. And we say that it might block because this thing might cause main thread IO. And so that works. I've got the patch built here. We can show you. I can show you right now that this works. So I'm creating a new profile probably from scratch here. Yeah. So these are the. Oh no, I had a pre-existing profile that migrated forward. That's good. So these are thumbnails, for example. This is a. I think this is working. Hold on. This is a thumbnail that's coming from my blog. That's using Moz page thumb right there, and that's working. Why isn't this one working, out of curiosity? What's this using? Moz page thumb, thumbnails. That's just showing blank.jpg for some reason. That's not my problem. I suspect that that's something different inside of our activity stream code. Or it just chose, the background thumbnailer chose the wrong site. I'm not entirely certain, but that is not, if that's a bug, that's not in scope. The Moz page thumb stuff, that's the real good stuff. Like Moz page thumb there, that's great. I don't know if these are Moz page thumbs. Yep, that's a page thumb. That's a Moz page thumb, and these are working, and these are running in the privileged about content process. And I made it so that if you disable the privileged about content process, we fall back to using the old blob URL mechanism. I'll show you that in a second. So I'm going to disable the separate privileged content process, so that disables the privileged about content process. Now let us restart. And so now these thumbnails are using blob URLs, which you can see a blob URL right here. I don't know if you can read that, but that's a blob URL. And that's something that's how it currently works out in release right now. But the problem with a blob URL is that you can't persist it between. It doesn't persist between sessions, and we need persistence between sessions for our caching thing, our caching project. Which, if you're not familiar is like what I've been working on lately is being able to cache about home periodically, and that actually works. So like now, if we check out some of these later patches that build upon, sorry, not tip, I want to check this one, let's build upon the Moz page thumb stuff, then we can actually start generating our cache. So let me show you that next, generating the cache. The Moz promise stuff is pretty neat, and it also demonstrates something that we've been, not myself personally, but people in the sort of the lower level XBCom engineers in Gecko have been working on, which is trying to like make our threading story really sane. So here's a lesson, a software engineering lesson for people who might be doing like concurrency and multi-threading stuff, is that it is tempting to think of threading as like almost free computation. Because what you're doing is you're moving work off to a different thread, maybe it gets assigned a different like core in the CPU, and that's great. You know, if you can take care of the multi-core processors that are being built these days, that's great. You know, it's great for responsiveness. The more you can take off the main thread, generally the better. But it's not free computation, and the more threads you have, the more competition there is for the operating system to choose which thread's getting serviced. And you can internally set thread priorities, and you should probably be like lowering the thread priorities of things that are background tasks. We currently don't do that directly at the operating system level, but what we've been trying to do is kind of like almost like cable management. Whenever you're like doing, like, if you have like a lot of cables with a piece of equipment, maybe you're working on like a computer tower or something, and you're trying to do cable management. It's a similar story with our threads and threading. You want to have you don't just want to spin up threads when you need them and throw them away. You kind of want to have a pool of threads that you can prioritize dispatching events to and receiving messages from. So that's more sane. Because right now in Gecko and in Firefox, for like, it's been multi-threaded for years and years and years, and in that time, people have like taken advantage of how easy it is to create threads in C++ to just create lots of threads, one-off threads that just kind of don't do anything or only do things in certain conditions. This music's a little loud. I'm gonna turn it down again. And so now we just have like a bunch of threads competing, and what we really need to do is get that under control and sanified, a thread pool, a controlled thread pool that can be prioritized. Maybe one I/O thread, for example, for spinny disks. You know, if you're spinning Rust, if you've got a hard drive that's got like a seek head, you don't want to have multiple threads all simultaneously trying to ask the operating system to seek to different parts of the disk, because you're going to incur overhead as the read head moves around on the disk. Ideally, requests from the disk, I mean, the operating system does some work to try and like reduce the amount of seeking, but I don't know if we really want to count. We want to be a good citizen, and one way of being a good citizen on the operating system is to like kind of cluster your I/O, your disk access, so that it happens serially and not like all at once. And some I/O is more important than other I/O, so having a prioritization in that channel of I/O requests is really important. Okra says Rust compiles so long. Yes, it does, but the good news is that I'm using what's called SC cache, which is a tool for caching the binary components that Rust creates and Clang creates for C++. And so subsequent builds should be faster for me. The reason it actually took so long just now is because I recently pulled from Central just this morning, and I hadn't done that in a while. So my SC cache is a little out of date. So I'm saturating it now by doing more and more builds. Anyways, so let's run this build. Okay, so we've got, I think I need to reactivate the privileged about content process. Privileged. We need to turn that back on, and then I'm pretty sure the cache is on. Cache about home. Whoops. Cache is enabled, and I am logging. So what I'm going to do is I'm going to shut down now, and now we are going to run. So this is actually being pulled from the cache, and it wasn't perfect. I don't know if you caught that, but let me restart and I'll show you again. Because, well, first of all, how can I prove to you that this was pulled from the cache? I can do that by inspecting the markup and finding that it's loading the about:home JS cache script right here, and you know, it pulled all of this stuff down out of the cache. It's going through the cache code path. And I should probably like somehow decorate the generated page so that it's easier to detect that it was cached. That might actually be a good thing to do actually right now in the markup, now that I think of it. That might be a thing we can do today, just to make it easier to find that to detect that the page that we're looking at was cached. There's also like this preloaded Boolean flag that's set on the window whenever that occurs. I added that, and that's useful for some of our activity stream code. But it wasn't perfect, and I want to show it to you again. Just pay close attention. Hopefully the frame rate is sufficient. You can see what I'm talking about. What I want you to pay attention to is the like all of the activity that occurs when the page, the initial about home page loads. Because what happens is there are a couple of flashes. It's not all like boom, done. It like reflows itself and rejigs itself. Did you see that? Let's do it again. Particularly these pocket stories. And notice that these two also kind of like updated. They like flashed a little bit. Yeah, Smurfy says you can see it. Okay, so that's not a great experience. The good news is that we're pulling this stuff out faster, and you know, we're not over burdening the first draw of the page. but we are overpainting. Like, as soon as it loads, then we like start spamming this page with a bunch of events or some information that causes it to like recalculate itself and update. And I like to skip that if possible. I want to show you the ideal scenario. And I can show you the ideal scenario by actually disabling activity stream so that it's inert. It doesn't run. So that we just load this static document and then no events start coming down from the parent. So let's check that out. So this is the ideal state, the ideal scenario. Load. Now there was, actually I shouldn't have said ideal because it's not ideal because we still see the flash in the pocket stories, but we didn't see the flash up here. And I can tell you why we're seeing the flash in the pocket stories. And the secret, or the reason we're seeing the flash in the pocket stories, I found this out yesterday. We can actually look at the cache entry. It's a little tricky, but if we look at the cache entry, so one of the things that happens, oh, you know what? This is a cache that kind of half fixes the issue. So I'll explain what's going on. We have some code inside of about, oh, I've disabled about new tab. I'll open one over here. We have some code in about new tab that does some an optimization so that images only load whenever they're scrolled in. I want you to pay attention to the pocket stories as I scroll up because they're going to fade in the images. Maybe that was a bad example. Let me try again. Yeah, I don't know if you can tell, but like at the very bottom, you can see like they're fading in. How does that work? Can you see that? Smurf D, are you seeing that? Hopefully you see that. It's like a subtle effect. And the reason for that is so that we don't overburden the page with image requests. If the user just wants to open a tab and go somewhere like to Reddit or something. We don't want to have spent the time painting images that the user was never going to see in the first place. And the way that works is actually using the intersection observer API to notice whenever these images intersect with the viewport. And the good news is that lately there's something we can use that's better. Hold on. Let me explain the relationship between that and the flashing though. So this cache is generated, and currently when it's generated, in fact, like if I do it right now and generate a new cache, let me generate a new cache and write it. Wrong process. Oh, what? Wrong process type. What? Did I just break myself? I need to investigate this. Hang on. Wrong process. Wrong process type. Is privileged process. 56749. That should be the privileged process type. Ooh, it's mystery time. What the heck's going on here? Process 56749. 56749. That is privileged content. That's the right process. So why does it think that it's the wrong process type? Let me see here. Services app info remote type. Oh, is null. Services app info. Remote type is null. Did that happen recently? I have a feeling this may have happened very, very recently. Why would remote type be null? And that's under app info? Info. Who implements NSI app information? App info. Remote type. Services.jsm. What is app info? App info is Zool app info. Okay. So who implements this? Get remote type. We're gonna assign it from the content process, this thing. Do I have the wrong process selected? Services, app, info, process ID? Which process? 56747. Oh, I'm in the wrong content process, that's why. Oh, because I have the parent process console selected. That's what was going wrong there. Whoopsie daisy. Whoopsie daisy. Let's try that again. So we're gonna generate, right. So we've constructed a cache. Good. Why is this, oh, I'm trying to sort of summarize what's going wrong here. Okay, let's take a look at the cache that was generated now. If we look at the cache, one of the things that's in this document is like the self-made man, the story of America's most pliable, pernicious, irrepressible myth. It's from slate.com. Now, is there anything in this cache entry? Unfortunately, it's really difficult to inspect the markup of a cache entry because it's all crammed to the edge. The binary data, the hex is prioritized, but we can look at the what's actually being written here. But if we look for slate, oh no, it's here. What the heck? Hold on a second. What is going on? Did I thought I generated a new cache. This is confusing. Give me a second here. I'm gonna blow away the cache and just start from scratch. I'm gonna blow away the cache. We have no cache now. Now I'm gonna start from scratch. So the page didn't load, great, because we don't have a cache. And now I'm going to generate a new cache. And let's take a look at it. Just have this one page, and it's like got 0 bytes. Did it not write properly? Oh, of course we can't construct. Here's why it's not working. It's because I have to turn activity stream back on in order for us to receive the state to construct the cache. So in my zealousness, in my attempt to demonstrate and show off, I hobbled my ability to debug. My bad. All right, so let's generate that cache again. There. So now we should see in about cache, should be one for about home. So here, the social distancing culture war has begun from the Atlantic.com. Why can't I find the word Atlantic or even Atlantic? Like, where is it in the markup? And the answer is it's nowhere in the markup. And the reason for that is because of that observer notification code, like the intersection observer code that we currently have. So when we render the page using the state inside of the React DOM server cache worker, there is no viewport. There is no notion that any of the images have been like brought into the viewport, so none of them are visible. And because none of them are visible, none of them render. And because none of them render, the cache markup that gets generated doesn't include any pocket stories. It includes like placeholders, but that's it. And that's why even after you load the cache, you see that flash of loading the stories. Let's see that in action here. See, like there was that moment where they were blank. So what do I want to do about that? Well, the good news is that the mechanism that it's currently using, the intersection observer for lazy loading images and stuff, that's all, that was written before a new web API called, that was added, like this native image loading, lazy loading. Let me show you. Lazy observer. Yeah. So this is the bug I'm talking about. I filed it yesterday. And the idea is that, you know, the old intersection observer stuff we used can be supplanted by using this new API that was just landed and that's going out next week to release. And it's called image loading equals lazy. So on your own sites, if you've got images that are outside of frame, you can improve the perceived, like you can reduce the load on the user's browser by adding this loading equals lazy attribute to the image tag. And what that does is it does the intersection observation stuff, but natively. So you don't have to implement it yourself in JavaScript. So for example, if I load this demo page, there's all these cats on this page. This is a very long list of cat images, but you can see that as I scroll the page, I start making network requests for these other, hang on, the console's getting in the way. I'm making the network requests for these other images as they scroll into the page. So that means that ultimately the page loaded like more quickly. Like it didn't have to load all those resources. I didn't have to waste time getting all those images unless the user scrolls to it, which is what About Home is trying to do, but it does it natively. So if we can just switch to that, that's good for a couple reasons. One, that will reduce the complexity of the About Home code because we don't have this hand-coded intersection observer stuff. And the other thing is that we can then make sure that the cards get put into the cache, as opposed to like the current situation where, because we're doing the intersection observer stuff dynamically, React is hiding the cards until the intersection observer fires. There's a question in the chat: does it create some kind of lazy object for each image, or are they created when needed? I believe what happens is that a placeholder is put in place of the image. Let's double check. Let's look at the source here, how this works. Yeah, I mean, what's best is if you are able to encode the dimensions of the images in your image tag in general, like automatically. And that way what happens is a rectangle of these dimensions gets put into the flow of the document without having to load the image. And then as you scroll in, then that rectangle, that empty rectangle, fills with the image. So that's what I want to try today. Let's see if we can replace the intersection observer stuff inside activity stream with this image loading equals lazy. So I proposed this yesterday. Scott Down, one of the engineers who works on About Home these days, and who originally wrote the intersection observer stuff, he commented back. He says, it's worth looking into, but it's probably also worth mentioning that there's more to new tab loading than just lazy images. We use a combination of request to idle callback and intersection observer to do a bunch of overlapping, to try to mitigate this, not all related to images. Images above the fold are loaded immediately and not lazily. I suspect loading equals lazy covers this, but this is what screen recordings would validate. We also load some below the fold React components lazily using intersection observer and request idle callback, whichever comes first. It's just prioritizing React to render the important bits first. We saw some load improvements with this, and was needed to initially get the last few milliseconds we needed to get in the green. Below the fold images within 540 pixels of the scroll range start loading. This is behind request idle callback or intersection observer from step 2. If they are still scrolled to before loaded, we use a tiny transition to make it look less jarring. The request idle callback on images is probably removable and unnecessary in the current implementation. So what he proposes is remove 5. It's probably dead code now. Test/record lazy for supporting 1, 3, and 4, and possibly move some or all of the functionality into 2. In the end, I think we'll reduce complexity on an image component a lot and just have the lazy in there. Increase the complexity in card component a bit, but I think we'll have a net positive complexity reduction between the two components and maybe a tiny performance improvement. That's presuming the lazy attribute is more efficient than setting up intersection observers and idles, which we don't know. That's a theory, but it's worth looking into. And the more we can use native stuff, the better in general. So I think this is what I want to work on today, seeing if we can do this. So let me create I've got a note here already. Let me share it so that you can follow along. I'll put it in the agenda. Did our music end? I think our music ended. Let me restart it. We'll just play that album all over again. This is Broke for Free on the Free Music Archive, starting with As Colorful as Ever. It's playing. It's playing. It's just really quiet. Okay. Now, the thing is, I can probably do this in isolation. And I don't have to do it in the stack where I've got my caching stuff. And that's good. That's the same thing with the Moz page thumb stuff. I'm actually able to do it in isolation. So it can land independently. So let's start by updating the central. And building. Yo. Gotta make those images lazy. With new web, it's super easy. You put the attribute on the node. That's all you do in your code. You don't need an intersection observer. Believe in yourself. There you go. Yo. Waiting for this build to be done, and then we can have a bit of fun. Inside the editor I'm using today, it's Sublime Text. I hear it's pretty great. It is. I don't mind it. I know the cool kids are all using VS Code these days, but I'm still partial to Sublime. Alright, while this builds, let's take a look at the code we're going to be touching. So there are a couple of places where this like lazy stuff was added and where it's used. Here's some of the bugs where they were added. Let me see if I can find like the commits. We can take a look at the raw commits to see what was touched. Wow, a lot of stuff in here. This is older code, and a lot of this is like all kind of clumped together. In fact, maybe I should look at the pull requests instead. This was back whenever ActivityStream was doing all their stuff on GitHub. I'll turn optimization on and off. That'd be useful. What's going on? I don't really understand that. DS image to all DS components. DS stands for Discovery Stream. Why were we logging before? That's crazy. DS image. Before we were doing a div, now we're using a DS image. So here's, for example, a place where we could use lazy equals true, or loading equals lazy. So DS image is going to be important. DS card, which uses DS image, may or may not be important. It's probably not important. But DS image kind of sounds like the important place. Let's also look, we'll use searchfox, DXR, searchfox, new tab. Let's look for image inside of JSX. We've got inside some of our templates, simple below search snippet. So let's not worry about the snippets. It looks like DS image is where it all is. DS image. Okay. So just one place. But let's also double check by looking for other intersection observers inside new tab. Intersection observer under new tab. DS image, there's something for DS card as well. So the cards themselves won't load until they are intersected, and then the images won't load. So let me do this in two steps. Do I want to do this in 2 steps? Intersection observer. It's on scene bind this. These aren't images. They're image wrappers. So we might actually have to keep this one, which is a problem because we want the cards. All right, here's one, let's look at the other. Yes, image. For each image, as soon as we mount, we set up ourselves an idle callback on ourselves, and we also set up an intersection observer on ourselves. Assume an image will be eventually seen as within half the average desktop vertical screen size. That's interesting. Then and only then, if we are rendered, if we say we have been seen, we render this image here inside of a picture class, or a picture node. Okay, that's interesting. So there's a picture node. What's it? I don't think I'm familiar with picture. Oh, it allows us to have different versions, different display scenarios. Okay, cool. Yeah, I learned. So this image is what's important because that's what we can put on, like make it so that it loads lazily. Then what I'll do is we'll start with DS image first. Let me start writing some of this stuff down. Okay, there are two layers here almost. DS card and DS image. DS card and DS image are similar in that they only render themselves upon intersection with the main viewport. Intersection with the viewport, unless we hit their idle callbacks. So they'll also use their idle callbacks. We can't use loading equals lazy for DS card because it's not an image. So for this, instead, we should probably have a special treatment for when we're creating the preloaded page. So that all cards are rendered. So perhaps some kind of special state flag that can be read. For DS image, I think this is ultimately going to result in better code maintainability, but doesn't solve the entire problem where the cards weren't being rendered into the cache. That'll have to be solved by another mechanism. But at least we can simplify, at least we can make it so that for the images that appear in the cache, we don't have to do any React-y swapping of nodes due to intersection idle callback. This will reduce flicker. So, 2 layers. We'll start with DS image. How does it work? So this is a React pure component. What does it render? It ultimately is going to render this picture node with an image inside it. There's some class names and some properties on the image. And it seems to switch between a couple of different states depending on, for example, whether or not state is seen as it exists and is true. If not, then I think we fall through to just showing the picture element and no image. I think we just showed the picture element if state is seen doesn't exist, or this dot state doesn't exist. I guess that's like the worst case scenario. We somehow rendered and we were configured incorrectly. I don't know. Oh, but if it is seen as false, we'll also just render like nothing. We'll just render an image, a picture with no image inside of it. That's interesting. I guess that makes sense. Instead of showing an image that has like I guess this is how you add the image. What am I trying to say here? There's no such thing as an image tag that doesn't have an image associated with it for the before state when it hasn't been seen. I think we can bypass this. And then there's this like class name. State is seen, then you have like the loaded class. What is that? DS image. Loaded. I think there's like a SAS thing, DS image. Or is this generated by hand? Like I have a feeling there's like an SCSS thing. New tab, yeah. DS image. Here we go. DS image. Whenever it is loaded, you set its opacity to 1. And if we have use transition set, then we transition that opacity. Okay. So use transition, who's deciding on that? The idle callback thing. So by default we don't use a transition, but then on an idle callback, as things load in, we ask to use the transition. Okay. The DS image. All right. Now, how does this other stuff work? Who sets up, so on component did mount, we request an idle callback on ourselves, and we also set up an intersection observer. scene. If this prop's optimize, set state is seen true as soon as it's seen. But if we ever hit the idle callback, then we end up using the transition. Okay. I guess we probably want to continue having that effect so that it's less jarring. I wonder if there are any like best practices or examples out there. Hello, Void Lux. Easy loading fade image. Whoa. Loading equals lazy. Beep boop. That was back in 2015. I'm looking for something. I think I looked at this before. Native lazy loading. Are there like special CSS rules? All images in iframes are above the fold. Load normally. Those are far below the fold. Are only fetched when the user scrolls near them. The distance threshold is not fixed. It varies depending on several factors. I wonder how. This is for Chrome and Chromium. To prevent the surrounding content from reflowing, make sure to add height and width attributes. Images that are defined using the picture element can also be lazy loaded. That is important for us. Can CSS background images take advantage of load? No, is there a downside? Intersection observers for elements are above the fold. A device fold may not fire before the window load event, and the lazy loading functionality relies on an intersection observer. There's no issue to modify. It's safer to use the loading attribute for elements to prevent late fetches of on-screen elements. Supported in 75. Lazy size, okay. Okay. I need to know about like, are there CSS like selectors for the lazy load thing? Anything I can use? You know what I should really be doing is looking at the bug that it was implemented on, because I have a feeling there was like some documentation. Lazy. Load event fires and the eagerly loaded content has all been loaded. It's entirely possible that there may be lazy loaded images that are within the visual viewport that haven't yet been loaded. You can determine if a given image has finished loading by examining the value of its Boolean complete property. Okay. So it's almost like we want to make it so that images, instead of using loaded is seen for loaded. Does it fire an event? The load event fires loading event or the loading event, image element. Loading errors. What about events? Experimental. Events. Image loading event, JavaScript. Hi, is it possible to have a Firefox extension send a notification of making a loud sound like that? I don't know if it's possible to make an extension that does that, because what we're using is like the operating system notification system. So it's more like you have to tell the operating system to not alert you that loudly. We're basically handing the notification off to the operating system. You could disable the notification system if you'd like. Yeah, so I think an image fires a load event on load, so you can like, an image will fire a load event. Okay. I'm trying to just figure, so why is this so hard? What am I doing? I'm trying to like maintain the effect that we currently have. I'm trying to make sure that this all makes sense. Like, we want to transition images that are loading below the fold. We don't want to transition images that load above the fold. So what we should do how does this work too? Like it uses the observer root margin on the intersection observer. I have to refresh my memory. Root margin. Root margin. Margin around the root can have values similar to the CSS margin property. The values can be percentages. The set of values serves to grow or shrink each of the root elements bounding box for computing intersections. The root intersection rectangle can be adjusted further by setting the root margin. Find offsets added to each side of the intersection root's bounding box to create the final intersection root bounds. This causes the observer to watch for changes in the intersection between the target element's bounds and those of the viewport without any added or subtracted space. Okay. I think I get it. Assume an image that will eventually seen if it's within half the average desktop vertical screen size. So we like add. You're adding the margin. Sorry, I'm kind of learning this as I go. Root margin. Stringless syntax similar to CSS margin property. Each side of the rectangle represented by a root margin is added to the corresponding side in the root element's bounding box before the intersection test is performed. The root element. And the root element in this case is the bounds are being treated as the bounding box of the viewport for the element, which is the observer's target. Right, so by default it's the viewport, so we're adding a margin of 540 pixels to the viewport. Adjust the bounds outward. Oh, it adjusts it outward. Lets you, for example, adjust the bounds outward so that the target element is considered 100% visible, even if a certain number of pixels worth of width or height is clipped away. What do I want to look at here to help me build my mental model? Room margin isn't specified when the object was instantiated. So it's like a margin, it's on the outside. Right, margin. It always goes on the outside of the element. So this is, let's shrink the window here. So this is our viewport. So by adding a root margin of 540 pixels, you actually create an additional, like, let's say a chunk, so that it's like this big around. So any item that suddenly floats into this region is considered visible, and then we run its intersection observer. That's what it means. Okay. So if it's within half the average desktop vertical screen size, then we start loading it. Okay. So what'll happen is that when all of the initial images go in, a lot of these observer notifications are going to fire. And we'll say, you've been seen. And use transition, which starts as false. So you've been seen, and because it wasn't on the idle callback, I see. So only the images that are still not seen by the time the idle callback fires do we add the transition onto. And if it's loaded, then we set the opacity, which is what we animate on with use transition. I see. I think no matter what, if we have state, non-optimized image failed. What is this? On not optimized image error. Some function. What is that? Is an error element if you try and add non-optimized image, and then whenever we say non-optimized image failure, we say non-optimized failed is true. Sorry, let me go back to the source. Image we set non-optimized image failed is true. So we'll skip over this, and then we'll go to broken image. Optimized image failed. What does this mean? Okay, so it's like we try a couple of different images that we can load. Optimized image error. what's the default? Optimized image fail is false, and so we try and get the optimized image. So we'll, by default, we'll enter here. And then we get the container width. But that's only set if we've been seen. Right, okay, so we've been seen. Oof, and we get the, okay, we get the bounding client rect width and the height, okay. We round it. We create an image URL for the right image. We create another one for the 2x source. Image source set. What is source set? Oh boy, learning a lot today. Oh, responsive images. You can choose different sizes, okay. Interesting. So as you like shrink it down, I guess the idea is that like these images become like more optimized for the display as you change the size. All right. Interesting. And we say whether or not, if there's an error loading this, then we say, hey, there was an optimized image error. So then we'll say optimized image failed is true. And so then we will skip over this next time. And we'll try again with a non-optimized image. So we'll say, hey, load a non-optimized image. And if that fails, then we fall back to broken image. Holy smokes, so this is pretty complicated. We like, okay. I actually don't know if using loading equals lazy is gonna help us here. There's so much complexity here because of the effect that's we're doing in the attempt to get like just the right image size, and I don't know if loading equals lazy is gonna help here. I think for the purposes of like the cache, what might be simpler, let's go back up to the experimental cache rater patch and rebuild this. What might be simpler, because we should opt for simplicity. Like no matter what, one of these three is going to be chosen, right? It's one of this, this, or this, and I think by default it's going to go with this, unless it's been seen. Oh, unless it's been seen. Otherwise it's empty, right? Otherwise it's been empty. Maybe that's where loading lazy can help, so that we're not injecting these image elements dynamically. Let me write that down. Part of maybe where we can, where lazy, loading equals lazy can help, is to avoid having to manipulate the DOM by inserting image tags when the image crosses into the intersection. Right now, that's currently how it works. And then there's this complex fallback mechanism in the event that the optimized images can't be retrieved. Okay. We had the intersection observer, and then right away, the ones that will be seen. Sorry to wake you all up. The things that are seen immediately will enter this callback because they're intersecting. We'll say, you've been seen, yo. You've been seen, then we insert the image element. So maybe what we want to do is remove this condition so that no matter what, we always, unless something's gone horribly wrong, we always enter into here. Say loading equals lazy. That's the API, right? Loading equals lazy, yeah. And even for this one, loading equals lazy. Failure to do any of those things results in just this div. Things fail completely, but at least this way we get our image element in there automatically. I think this will still accomplish the effect. So that's one thing. The second thing is that these cards aren't going to be rendered unless I'm gonna do something really bad to experiment. I'm gonna say if not seen. For now, I'm just going to get rid of this, so that no matter what, we just render the fragment. And that's not something I think we want to do, but I'm going to do that for now. Now, for activity stream code, we have to run this all through this thing called Webpack, which is this annoying thing. But there, it's done. And now I can build faster and include it in the packaging. There we go. Okay, so now let's try and recreate our cache. I believe if we look inside the cache, about cache, we'll see, for example, this stuff, like Brooklyn. Let's look for the word Brooklyn. Brooklyn, yeah, it's there. And the image, is the image there? Picture, DS, image, picture. The image does not appear to be included. So that part's not working. Why not? DS image. Oh, I guess because there's no observer notification that's going to fire for this as well, so we're going to fall back to this. Well, no, hold on. We should have chosen one of these. No? Which one did we choose? We chose like nothing. If this state... I guess state must have been empty? That doesn't make sense. No cache. Picture. TS image, there's the class, and it's just an empty image. There's another one. No images. Alright, I think we have to figure that out. Was it just that, like... Why is there no state? Rendering DS image. I can do it this way, I guess. Well, no, we're doing it inside of a worker. That's okay. Rendering. And then this dot state. Let us now build again, the outer build, and then we can take a look and see what the generated cache would be. So that did not look great. That load just whoops, wrong console. Rendering DS image. So it does it. It is seen false. Optimized image failed. False. Use transitions false. So it should... You know what I should have said was like console log image. That's what I should have added. One more time. Camera and bundle. Here's a pro tip. You can go back to the previous directory with CD space dash instead of having to like CD a bunch. You just go back in one move. Okay, let's generate us our cache. Undefined. Why? So we do have a state. So why don't we fall through this? Which one are we? Oh, we probably enter one of these. No, we don't enter one of these. We don't enter this one. State container width. Right. Because we don't have any viewport. We don't have any like dimensions. Oh, that's gonna be tricky. So we don't have any dimensions. Whenever we're running like this inside of a worker, we don't have any dimensions to work with. We don't have an intersection observer. For now, I'm just going to say source is this dot props source. I'm just gonna do something like this. Say source equals this.props dot source. We're not going to do the source set thing. All right. This is gonna. Oh, what do you not like? What do you not like when you do? Doesn't like something, you know. Oh, because I opened a bracket here and I didn't. No, I closed it. What are you talking about? If unexpected. Oh, because of this? Is that what you want? Does that make you happy? Now it doesn't like this. Oh, because I need a... Sorry, I need that. That's what I need. Those in parens. I don't actually know how that song goes. Speaking of music, we're back. Those loaded poorly. Let's try that again. Oh, hang on. Let me generate the cache now. Did that even work? Because I didn't log an image. Oh, here's one. Here's another one. Where are these coming from? Are these happening inside my worker? These sort of like rando I don't get it. Don't get it. What's happening here? Source. Log. You know what? Let me use a breakpoint inside my worker. Will it let me set a breakpoint inside of a worker? Nope. Maybe the multiprocess toolbox. Content process 74463. Here's cache worker. All right, that's what I wanted. So we're gonna set a breakpoint here, and then console has a DS image. Here we go. Let's set a breakpoint here. And now, in 74463, we'll run this. Our script for generating the... I'm just going to copy. Okay. Say, boom. Start cache out, construct. What? No, I want to be running. What, do I have to tell it which process I want to be running in? I have to like choose that and then like open up a create, construct. Wrong process type. How do I choose in the console which process I'm executing in? I feel like this was something that was enabled recently like that. I was allowed to choose the content process. Well, I'll use the content toolbox then for now. All right, and we hit our breakpoint. Good. So we're inside our worker. All right, so we have this. So we decide we're gonna construct this image, and we log an image. I don't know. Oh, maybe because the worker. No, why didn't we log that? So we rendering DS image. I see that logged. And how come we don't? Does that cause an exception? No. So why didn't we log that? All right. Well, the good news is that it looks like the images are being generated. So let's shut down and restart. Not amazing. Still not amazing. See, it reflows and reconstructs the page. That one was better. So part of the challenge here is because we do so much optimization based on like the constraints of the document. I wonder if we need to send more hints into when we're constructing the cache on what the display size is. That's kind of a pain. I think what I need to do is study this a little bit more. Container width, container height. Like what it's doing is it's looking at the bounding client rect and height whenever an image is seen. And that's just the image dimensions, isn't it? Shouldn't it be? I think I need to understand this more. I'm gonna dig into this a bit more. But now I'm starting to think that maybe this isn't so much me being like screwed by the fact that I'm inside of a worker and I have no viewport, and more that I'm just confused by this code. As soon as a thing is seen, if we say props optimize, we say your container width should be like calculate what your bounding client rect width is for an entry, for intersection. For whatever we are, which is the DOM node, which is this picture. So it finds the dimensions of the picture and then asks Pocket for the precise, for an image that will be perfectly suited for that dimension. I think I need to stop and think about this for a while. I'm gonna pause here. I'm sorry we didn't actually get to write any much code today, but we were exploring. I'm learning a lot about DS Image and DS Card and React and how all this stuff works. I have to think about it, I think, for a little while. Specifically, this image optimization stuff. It happens so dynamically, and I wonder if there's more we can do declaratively. I don't know. How am I gonna do this inside of the worker? That's what I need to figure out. Because ultimately, what I want to make sure of is that whenever we're generating these cards, whenever we're generating the cache, we're producing the most optimal page possible. That's my goal. And so having it like recompute itself after it gets hydrated by React is not a good, it's not a good idea. It's gonna rethink itself, and I don't want it to do that. All right, I'm gonna have to think about that. I'm gonna end it here. Thank you so much for watching episode 210. Was that the episode? Yeah, 210 of The Joy of Coding. I hope that was interesting. Stay safe out there. Wash your hands. You know, if you're with your loved ones, I hope you're not getting crazy with one another, and like, I hope you don't want to, you're not at the point where your loved ones are now also your enemies. You know, just, we're gonna get through this COVID-19 thing. We just got to keep pushing through. Stay inside. Don't infect people. Thank your healthcare workers. And if you have volunteer opportunities in your area to help the local hospital, maybe by helping to make PPE, that's personal protective equipment, or donating money, or if you're, I mean, you might be a programmer, especially, like, I'm guessing that if you're watching this, you are into software. There might be software projects that can help your local hospital or healthcare workers. So look into it. You know, we all have to pitch in. So I'm gonna end it here. Thanks so much for watching. Stay safe, take care, and I'll see you next week. Let me just transition. Bye-bye. Oh, don't tell me the WebSocket collapsed. Hold on.
The joy of coding.
See ya.